In this video, I want to have a look at proving trig identities. So to prove a statement, we need to show that the left-hand side of the equation is equal to the right-hand side of the equation. So what we're going to do is we're going to start with the left-hand side and we're going to manipulate it until we end up at the right-hand side. So let's have a look at an example. So our first example asks us to prove that cot A plus tan A is equal to cosec A sec A. So we're going to start off writing left-hand side is equal to, and we're just going to rewrite that left-hand side of the equation. So cot A plus tan A. Now these sort of things, it's not always obvious how to get from one side to the other, especially when you first start doing these. So it's really important that you just sort of play with it, manipulate it how you can, and see if you're getting closer to the answer. So the first thing from our trig identities that we should know is that tan A is sine A over cos A, and cot A is the reciprocal, so it's cos A over sine A. So we're going to write those down. All right. So now we've got this, which is looking a bit closer because our answer doesn't have any tans or cots in it. It doesn't have any coses or sines in it either, but it does have the reciprocals of coses and sines. So we're sort of moving in the right direction. Now ours doesn't have any fractions in it. So what I'm going to do, I'm going to simplify this fraction. I'm going to make it into one fraction. Now to add fractions, we have to have a common denominator. So I'm going to multiply and make our denominator be sine A cos A. So that means this one's already got sine A as its denominator, so I'm going to have to multiply top and bottom both by cos A. So that'll give me cos squared A up here. And this one we're going to have to multiply top and bottom both by sine A. So we're going to have plus sine squared A. Now we know one of our identities is that sine squared plus cos squared is equal to 1. So that means this is going to give us 1 over sine A cos A. And if we split that in half, we're going to split it into 1 over sine A times 1 over cos A. And I've run out of room, so I'm just going to move up here. But 1 over sine A is cosec A. And 1 over cos A is sec A. And that is exactly what we're after. So we're going to write equals not left-hand side, right-hand side. So we started with the left-hand side, we've manipulated it right until we get to this right-hand side. And then we can just write a statement at the end. So therefore, cot A plus tan A, tan A is equal to cosec A sec A. Right, so that's our first proof. Let's have a look at another one. Our second example asks us to prove that 1 minus cos A over sine squared A is equal to 1 over 1 plus cos A. So same thing, we're going to start with that left-hand side of the equation. And we're just going to rewrite it to start with. So 1 minus cos A over sine squared A. All right, now one of our identities, the first Pythagorean identity, told us, I'm just going to write it shorthand here, that sine squared plus cos squared was equal to 1. Now if we want to replace sine squared with coses, we're going to rearrange this. So we're going to have sine squared is equal to 1 minus cos squared. So that's what we're going to replace our sine squared on the bottom here with. So we're going to have 1 minus cos A over 1 minus cos squared A. Now hopefully down the bottom, that 1 minus cos squared A, hopefully you're seeing that as the difference of two squares. So because that's the difference of two squares, we've got 1 squared and cos squared, we can factorize it. So the top's going to stay the same, but the bottom is going to factorize to 1 plus cos A, 1 minus cos A. Now 1 minus cos A and 1 minus cos A on the numerator and the denominator, so we can cancel those out. And we're just going to be left with 1 over 1 plus cos A, which is exactly what we were after. So we're going to write equals right-hand side, and then we need a little therefore statement. So therefore 1 minus cos A over sine squared A is equal to 1 over 1 plus cos A. Right, so like I said, these aren't easy when you first start. It's a lot of just fiddling around, putting things in, seeing what happens, and if it doesn't work, starting over and trying something different. So there's going to be a lot of mistakes that you make in this one, and that's good. That's okay. Just do it, see what happens, and you can start over if you need to. All right, so that's a few examples of proving trig identities.